morning, everyone. I am Rekha Baghel, Assistant Professor in CSC Department, AKGEC Engineering College, Ghaziabad. Welcome to the lecture series on operating system. Subject code is KCS 401. So today I am going to deliver a lecture on process synchronization. The lecture overview is, first we will discuss what is a process, what is the difference between process and a program. We will see few examples of process and program. Next, we will move to the process structure, how we can represent a process in memory, what are the different states a process goes into their life cycle. Next, process control block and process synchronization, and in the last, we will discuss about race condition. So, process we can define in simple way, like a process is a program in execution and a process is a active entity while program is a passive entity. This concept we can understand with the help of some real world example. Here, cooking manual and ingredients for cooking, we can take it as a passive entity. Why we are saying these are two passive entities? Because these two cannot create any useful or desired output like tasty dish without using some active entity. So, when the act of cooking is put these into execution, we produce some tasty dish. So, here in this program, the program is analogous to the cooking manual and the process is analogous to cooking. So, here cooking manual and ingredients for cooking is considered as a program and act of cooking is just like a process. So, we are saying that program is passive in nature. Passive in nature because it cannot create some useful result. For initially a program is stored in some disk, some hard disk. For execution, that program must be in main memory, or we can say program is a executable file. Program becomes process when executable file loaded into the memory. So, when we start a process, a program is loaded into the memory, some secondary memory. When we double clicked on particular icon, or we start particular file from the command window, then it becomes a process. So, one process, suppose we have a one text file. Suppose we have some text file save as a .c extension. When we start, we have a one file and that file is with the .c extension, means that is a C file here. We are using a C file, C language coding हम यहाँ पर कर रहे हैं, and a C file, then that file is compiled and execute first time, then that file have one process, that program is one process, and again we execute it second time, then it will also create second process. So, we can say one program is run multiple times, then it will create multiple processes. Means same program can have multiple processes. Okay. Next one, the examples of the process and the program. So, process, suppose we have a Chrome browser installed in our system. So, as we know, a program is an executable file. So, all we know that Chrome browser installed in your system is an exe file. Okay. So, when you double clicked on this browser and it opened in a browser frame, so it becomes a process. Another example of process is Notepad. When your Notepad is installed, Notepad is stored in your secondary disk, and you just open it from start menu and just click, and when the Notepad file is opened, then it becomes a process. So here Chrome browser and Notepad are the programs, and when they start executing, then it becomes a process. Structure of a process. Structure of a process means how we can represent a process in memory. Process must be in main memory. Okay, so how we can store a process in main memory? What is the structure a process contain? A structure of a process is like the main components of a structure of a process is stack part, heap part and data part. Okay, stack part, heap part and data part. This text data is also known as a program data. Okay, this is the program data, and we structure a process. It contains stack part, heap part and data part. Stack part contains the temporary data of a program. Temporary data like function parameters, return addresses, local variables, all these things are allocated into the stack part. Okay, and heap part contains memory dynamically allocated during the runtime. The memory allocated during the runtime is stored in the heap part. Okay, and data section part contains all the data related to global variables. So local data or temporary data is stored in stack part. Dynamically allocated memory during runtime is allocated in heap part, and this data part, this data section contains the global data. So what is the need of this categorization? Why we just distinguish between these sections? So one need that can just inspire for this categorization is, first is protection. Protection means when our team is working on different modules, so protection between the different modules is necessary. So by categorizing these sections, we provide the protection to the code. There is a global variables are stored in data part. Memory allocated during runtime is stored in heap part, and temporarily variables related data is stored in stack part. So we provide a different level of protection to these layers. So this is the basic reason of this categorization of data. Suppose here stack, first one is stack, and we know stack is a data structure which works in last in first out. It is a data structure means the recent element must be removed first. So all the temporary variables are stored in this section. Means suppose we have one program P, and this program P is stored in the memory, in the position like memory location is 1000 to 1020. So this is the memory location on which this program is stored. So we can understand this concept with the help of one example. Suppose we have one program P, and this program is stored in some memory location like 1000 to 1020. So this program is stored in this location from 1000 to 1020. So stack part always reside on the upper memory location. Upper memory location means 1000. What is the upper range? 1020 is the upper range. So stack part means 1020 here, and minimum range is 1000. So stack start storing the data from 1020, okay, and the this lower part is start storing the data from 1000. So stack is a data structure that works in last in first out manner. So this stack, if we want to just remove some item, then push operation perform. When we want to input some item, then push operation perform, and when we want to some item must be removed from the stack, then pop operation. Okay, these are the two operations that must perform for removing and inserting the element. So we have the upper limit is 1020, lower limit is 1000. Stack contains all the temporary data, that is addresses, function parameters and local variables data. So it start storing the data in this direction, okay, in downwards direction. So heap part contains the memory that is dynamically allocated at runtime. So this heap section start growing. So this heap part start going in upward direction. Okay. So this is the this is the structure of a process. Next, what are the different states of a process? As we human being have a life cycle, similarly a process have a certain life cycle. In that life cycle, the process goes into different states. When a process comes into the existence, then that state is known as a new state. And when a process is ready for the execution, okay, the process is ready for the execution. Process is allocated in the memory, but it is waiting for the CPU, okay, some active component. So ready queue, process is in ready queue, then it is in ready state. The process is waiting to be assigned to a process, then it is in ready state. Running state, when a process is in running state, when a CPU or we can say processor is assigned to a process, then it comes into the running state, okay. And waiting state, suppose process is running, but at some time it feels a need of some input output device. So our input output device is handed over to the process, and process start execution with the input output device. So now process comes to complete its input output related task. Now process after complete, now processor is released from the process, and at that time when process completes its input output related event, then process comes into the waiting state, means already processor is assigned to some other process. Suppose P1 is a process that is already running, but at some moment it needs some input output device. So it starts execution related to input output. At that moment, we released CPU from this processor, because this processor is actually starting the execution with the input output device, and we assigned CPU to some other process like P2. So when P1 process completes its input-output related task, then it is waiting for this CPU. So it becomes in waiting state. Waiting for CPU. Okay, then it goes in waiting state. Okay, and terminate state. What is terminate state? When process has finished its execution, then it is a termination state. So this is the diagram of a process that goes to in different states. So first state is ready state. When a process is admitted into the memory, then it is a ready state. And when a process is interrupted, when a process is assigned some CPU or processor, then it goes into the running state. And when a process is in running state, due to some input-output event, it goes to the waiting state. If due to some interrupt, maybe some high priority event, some high priority process can come, so that the previous process must release the CPU for the higher priority process. So now the previous process comes into the ready state. And when when the process completes its execution, then process is terminated. So here total 5 states are there: new state, ready state, running state, terminated state, and waiting state. Process control block. Process control block, we can say it is a task control block also sometime. And we can say a process control block is the data structure of a process. Every process that comes into the existence has its own PCB. For example, if there are 10 processes are in system, then each process has its own PCB. PCB has all the information related to process. Okay, so what type of information a process can have? First information is process state, means in which state, what is the current state of the process, means whether it is a running state, whether the process is in waiting state, whether the process is in terminated state, or whether the process is in ready state. So we just mention the state of a process in process state. And next one is program counter. This is the PCB block, then process state, process number, program counter, registers, memory limits, and list of open files. These are the different categories that a process control must have. First is process state, next one is program counter. Program counter represents the what next instruction is executed. It store the address of the next instruction. CPU registers means how many different registers a process have. So we just mention the CPU register related information in CPU registers. CPU scheduling information. Every process works on some scheduling algorithm, whether it is a first come first serve, whether it is a round robin, whether it is a shortest job first. Every process must have a scheduling information. So process works on which scheduling algorithm mentioned in this scheduling information block. Memory management information. Memory management information related information is mentioned in this block, and this is the memory management information. In this block, we just inform about the process, how much memory is allocated to the process. Okay, and accounting information, CPU used, clock time elapsed, since start time, time limits, all these data are mentioned in accounting information. Input output status information. In this block, we just write how many input output devices are allocated to the process and how many list of files are opened. Means a process, when a process is in running state and due to some input output event, a process can goes to the waiting state. At that time, if process is working on some files, those files are in open state. So we just find the status of the open files. Process synchronization. Process synchronization. What is the need of process synchronization and what is process synchronization? As we all know, operating system is act as a interface between, operating system acts as an interface between the user and hardware. So all we know, operating system does lots of tasks, done lots of tasks related to our jobs. So how the operating system manages all the processes? Because a process is related to one program, a user can run multiple programs at one time. How operating system manages all the programs and run perfectly? So a process, at a time, many processes are running currently. Concurrent process can be cooperative processes. What is concurrent process? Those processes which are running concurrently, means those are running at the same time, are known as a concurrent process. And cooperative processes are the processes that share some common memory. Okay. So concurrent process can be cooperative process, means at a time n processes are running and these n processes can have work on some common memory. So the way by which processes that share the memory space are managed in an operating system, so that no conflict between the different cooperating process is occurred. So maintain the consistency of the data by using variables or hardware, so that only one process can make changes to the shared memory at a time. This is a process synchronization and we will discuss it in more detail in further lectures. Thank you.